As soon as Neil Armstrong took those first meaningful steps on the moon, people's attention immediately turned to Mars, and they began to speculate about how we could land humans there. Thus, keep watching this video to see what the first 2 years of Mars will look like. The establishment of a colony. Before establishing any kind of colony on Mars, there must first be a significant amount of study carried out on the planet. Scientists and engineers need to find the best possible locations for future landing sites on Mars and the most efficient and safest ways to carry personnel and cargo to the surface of the red planet. It is anticipated that this will take some time, and it will need rovers and satellites to map out the planet's surface. When all of these tasks have been completed, private enterprises or government agencies can launch pods that hold components for the first base. These pods, which will transport everything from water to structural pieces for the base, will be dropped down to the place for the colony that has been chosen in advance. In addition, they will bring gadgets that will make it possible for the astronauts to generate these necessary components on their own, freeing them from needing regular supplies from Earth. This is beneficial for a couple of reasons. First, it will mean that colonists should be able to wait it out if there is a problem with one of the launches, and second, it will allow firms to reduce the number of rockets they have to launch, which will reduce the cost of doing business for companies. The fundamental prerequisites for existence on Mars. For people to survive on Mars in the first 2 years, they will need at least the following 4 things: water, oxygen, food, and shelter. At first glance, this does not seem to be too much of a problem, particularly because on Earth, humans are required to locate or produce water, food, and housing, and we are doing admirably in all of those endeavors. On the other hand, there's a great deal more to consider when sustainably producing these 4 goods on Mars. Water. Of the 4, water will be the simplest to find. Since up to 60% of the Martian soil is made up of frozen water, it would not be necessary to use a particularly complicated mechanism to extract the water from the ground. Digging up the ground and placing it in a device that functions similarly to a microwave to melt the ice and generate liquid water is one of the strategies that has garnered the most attention in recent years as a potential method. Oxygen. The oxygen production on Mars does not seem to be nearly as difficult as water production. The carbon dioxide content of the atmosphere of Mars is around 96%, and each particle of carbon dioxide is approximately 97% oxygen. This indicates that if sufficient supplies are sent in advance, astronauts will be able to work on constructing a big machine that will remove the naturally occurring carbon dioxide from the air, break it down into carbon and oxygen, and then provide the oxygen to the portions of the base that are used for living. Food! During the first 2 years of the colony's existence, food production will be challenging, and it will likely be far more challenging than producing water and oxygen. The difficulty is that the soil on Mars is not like the soil that can be found on Earth. For example, it is not nearly as favorable to the growth of crops as the soil that we use here on Earth is. In theory, this might be avoided by redesigning the seeds of the plants to adapt to the Martian soil so that they are not harmed by it. However, this would be extremely difficult to do, and it would take a lot of time and money. Therefore, most of the food that humans living on Mars consume would originate from Earth and be sent there in specialized vacuum-sealed packages. Shelter! Regarding the space station itself, each component must be delivered beforehand to accommodate the astronauts. In the beginning, the astronauts will have to construct the various components of the base and their lander. Therefore, it will have to double as a temporary residence for them to ensure that astronauts are able to maintain their regular breathing patterns while inside the space station. The facility will need to be pressurized. It will be necessary to construct the base out of cylindrical parts to accommodate the significant amount of downward pressure exerted by both Mars's atmosphere and the artificial atmosphere created inside the habitat to simulate the atmosphere of Earth. Additionally, it will be preferable to cover the base with a layer of dirt and ice to protect it from harmful waves of radiation and solar flares. The maximum exposure to radiation that NASA will allow its astronauts to experience before bringing them back to Earth is only 3 years worth of time spent walking about on the surface of Mars. Providing vitality to the core. It is possible to generate electricity in various ways on Earth, however, only a small fraction of these methods would make sense to use on Mars. One may first believe that solar power would be the ideal choice for Mars, but the fact is that because Mars is further from the Sun than Earth is, solar power is far from being as effective on Mars as it is on Earth. In addition, persistent dust storms may obstruct the sun's rays for many days, making solar panels completely ineffective at such times. Geothermal power is also not possible on Mars, since the temperature at the planet's core is substantially lower than Earth's. On the other hand, wind power seems to be a viable option, but to have enough turbines to power a whole base effectively, there would need to be an excessive amount of supplies and construction, while on the surface of Mars, for this to be a fruitful kind of energy. The installation of wind power would need too much time and effort at the moment, making it an attractive option only for the distant future. Thus, this leaves the option of nuclear energy, which is most likely the method that will be the most effective when it comes to powering a new Martian outpost. Even though it is risky, and if anything goes wrong, it might be disastrous, the astronauts shouldn't have to spend a lot of time or energy setting it up correctly. The use of rotating crews. It will be vital to have rotating crews to ensure the safety of all the astronauts engaged. Around once every 6 months will mark the beginning of a new rotation during the first 2 years the colony is in operation. In the future, when the colony has become more self-sufficient and established, the crews may switch places more often than once per year. As mentioned, the maximum exposure to radiation that NASA will allow its astronauts to experience before bringing them back to Earth is only 3 years worth of time spent walking about on the surface of Mars. Even if the precautions against solar flares and radiation are perfected, astronauts should not be permitted to remain there for extremely extended periods. This is because solar flares and radiation may cause serious health problems. The expansion of the colony. In the long run, an increasing number of humans will be sent to Mars. Even if they do not remain there permanently, they will be there for a time that is far longer than the first human expeditions to Mars. Eventually, it won't only be astronauts, engineers, and billionaires who go to Mars as the human population grows exponentially. It will be normal people. Even if it may seem like something out of a traditional science fiction novel, the development of actual urban centers on Mars may be possible as early as the year 2050. Mars may one day feature neighborhoods, commercial areas, educational institutions, and workplaces similar to those on Earth today. From that point on, nobody can say what the next step will be. And that wraps things up. We appreciate you watching this video. Please hit the subscribe button, and we'll see you in the next one.